Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can solve triangles using trig ratios. So when we talk about solving triangles, what that means is we are looking at finding all of the sides and all of the angles. Now, in order to do that with trig ratios, we do need a little bit of information. We either need to know two sides of the triangle and know that it's a right triangle, or we need to know one of the angles other than the 90-degree angle and one of the sides. So let's take a look at some of these trig ratios that we've been reviewing and how we can use them. So if we're missing a side and we need to find a side, what we want to do is we want to use our typical trig ratios, sine, cosine, and tangent. Now, sine, again, is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. If we're missing an angle, however, we don't want to use sine, cosine, and tangent, but we want to use their inverse functions. Now, remember, inverse is kind of the opposite of that function. It's how we would undo doing a sine, which is how we can solve for theta or our missing angle. So to do that, we're going to use either inverse sine, inverse cosine, or inverse theta. And what we put into that equation is going to be the ratio of the sides. So if we use inverse sine, it should be opposite over hypotenuse, cosine should be adjacent over hypotenuse, and tangent should be opposite over adjacent. Now that is different than our sine, cosine, and tangent, in which we put the angle that we know. So again, sine, cosine, and tangent are used to find missing sides based on knowing an angle and one of the two sides that we're calculating, or we're using in that ratio. When we're trying to find a missing angle, then we're going to use the inverse trig functions. So let's take a look at how we can solve a couple of triangles here. So here are two triangles. Now, solving a triangle, again, means finding all the angles and all the sides. Now, notice in both of these triangles, we have a little bit of different information. As stated before, to solve a triangle, we need to know either two of the sides and its 90-degree angle, or one side, one angle, and one angle in addition to its 90-degree angle. So let's take a look at how we can solve both of these. So let's first start with this one on the left here. Here we know two of the sides. Now we've got a couple of options on what we can do. We can either figure out what one of these angles are using the relationship of those sides, or we can use the Pythagorean theorem to figure out that third side. Now it's totally up to you. What I'm going to do is use that Pythagorean theorem to figure out our third side, and then we can actually use our inverse trig ratios to find those two angles. So let's do that. So this is a leg, this is a leg, this is the hypotenuse. So we know that 3 squared plus 8 squared, maybe, plus 8 squared. Come on. Technology. It's always awesome, isn't it? 3 squared plus 8 squared is going to be equal to that hypotenuse, or AB squared. So let's figure out what that AB is. Now 3 squared we know is 9, and 8 squared is 64, and 9 plus 64 is going to be 73. So this distance AB is going to be the square root of 73. Now 73 is, in fact, a prime number. And so because 73 is a prime number, we know that that's as simple as that's going to be. So then we can use these three sides to figure out what our angles are. So to figure out what this angle A is, what we're going to do is we can either use sine, cosine, or tangent. And it doesn't matter which one because we know all of our sides. Now for me to find A, what I'm going to do is I'm probably going to do my tangent, so opposite over adjacent. So I'm going to do the tangent of A is equal to our opposite, which is 8, over our adjacent, which is 3. Now to figure out what angle A is, what we're going to have to do is we're going to have to do the inverse tangent of that ratio 8 over 3. So let's figure out what is the inverse tangent of that. Well, if I do the inverse tangent of 8 over 3, I end up getting 69.44 degrees. So this is going to be 69.44 degrees. Now we can use another inverse trig function, or in this case, we can actually use the idea that we know that all of the angles inside of a triangle add up to 180. So we can say that 69.44 plus 90, and then subtract that from 180, and we end up getting that this other angle here is going to be 20.56 degrees. Awesome. So we've now solved that triangle. We figured out what all the angles are and all of the sides. So that's how we can do it when we're given two of the sides. Again, we can always use our trig ratios as much as we want, but trig ratios are another tool in our tool belt. We also know about the Pythagorean theorem. We know that the sum of the interior angles of a triangle add up to 180. So we can use any of those to figure out these properties here. take a look at our other triangle and decide how we can solve this one or find all the angles and sides in it. Well, we know that we have a 90-degree angle and this angle is 63. As stated before, we know that the sum of the interior angles of a triangle add up to 180. So the 63 plus the 90 only equals 153, which means our other angle is going to have to be, that doesn't look like it too, a 27-degree angle. Fantastic. So now that we have all of those angles, we can then use our trig ratios to determine what those other sides are. Now, what we've been given is our hypotenuse here. So because we have our hypotenuse, we can either use sine or cosine in order to find those other sides. It just depends on what angles we want to use. So I'm going to do the cosine of 63 degrees is going to be equal to this length BC, because BC is adjacent to 63 over 14, where 14 is our hypotenuse. So then what we can do is figure out BC, and that is going to be 14 times the cosine of 63 degrees. And when we do 14 times the cosine of 63, we end up getting that BC is equal to 6.36. This line here is 6.36 units long. Now we can either do the sine of 63 or we could do the cosine of 27. It doesn't matter, those will give us the same answer there. So let's go ahead and use the sine so that we can stick with this 63. So we've got the sine of 63 degrees. And remember, sine is opposite over hypotenuse. So that's going to end up being our opposite, which is AC, divided by our hypotenuse, which is 14. Now, again, when we solve for this, we can determine that AC is the same thing as sine of 63 times 14. And so then we can figure out what AC is just by doing that calculation there. And so if we do the sine of 63 times 14, we end up getting that that is going to be 12.47, or this distance AC is going to be 12.47 units long. Okay, so you've seen these two different ways that we can solve triangles. We have a bunch of tools in our tool belt that we can use to solve. So what are those tools that we can deal with here? Well, we've got the, as mentioned before, we have the Pythagorean theorem that we can use. And that'll help us find the sides of our triangle. So that'll help us find the sides. We know that the sum of the interior angles is equal to 180. And that obviously helps us with finding angles. And then we have our beautiful trig ratios. And remember, with those trig ratios, not rations, trig ratios, if we are using sine, cosine, or tangent, we end up getting a side of a triangle. If we use the inverse of sine, inverse of cosine, or the inverse of tangent, we end up solving for an angle. So that is how we are going to solve a triangle completely, is using these tools in our tool belt related to right triangles. If there are any other tools that you know, you're obviously more than welcome to use those, but that is how we can solve a triangle. If you have any questions, feel free to reach out, but that is solving triangles completely, finding all its angles and all its sides using those trig ratios.